Welcome to Financial Management. Today's topic is time value of money, which is the core concept of financial management. And this concept will be used throughout the subject and very important. After having this lecture, you guys will be able to understand the concept of time value of money. You will be able to understand the present value and future value concept and the relationship between present value and future value. Moreover, you will be able to get some know-how about uh, we will also discuss the interest rate and how the interest rate can be used to adjust the value of cash flows. Similarly, we will calculate the future and present value of some amount that is invested today. Let's start the lecture formally. Before going into further, we need to understand some basic and important concepts in financial management. The basic concept is time value of money and interest, of course, both are interrelated. So, a rupee today is worth more than a rupee tomorrow. This phrase can describe the uh, importance of time value of money. Similarly, a safe rupee is worth more than a risky rupee. This shows the risk and return concept. Discounting and NPV presents uh, that you don't need to compare apples with oranges. You need to compare apples with apples and oranges with oranges. This phrase explains the concepts of NPV, which is net present value. Another one is don't put all your eggs in one basket. This explains the concept of portfolio diversification. That when you have some investment, you have to put your investment in different baskets. Otherwise, if you put all of your investment in one asset or one company or one opportunity, and if you unable to get that get benefit or return from that, your whole investment will be lost. Get insurance because you will break some eggs. So you might you might have a risk in your investment, and it is obvious when you are going to do investment for the purpose of return, risk is always associated with that. So you need to get some insurance for your risk, that is hedging and management of the risk. So all these concepts are related to financial management, which we will discuss in this subject. Now comes to the definition of time value of money. Time value of money explains that the money or a rupee you have in your hand today in your hand is have worth has more worth than the rupee you will get tomorrow. For example, you have 1 rupee today, it is not equal to 1 rupee that you will get tomorrow. Why? The reason is time an opportunity. Today, you can invest this rupee or money into a bank and you can earn interest on it, that is return. And the return will always need some time. So the this time is important. The money you have today has more worth than you will get tomorrow if the money is same. The amount is same. That's why in finance or financial management we measure the future cash flows or future income on the basis of today, and then we take some decisions. So the major concepts that we are going to go through in time value of money concept, uh, we will discuss about interest rate, simple interest rate, compound interest rate. Then we will go to find out the value of some amount, uh, and we will learn how we can uh, find out or calculate the present value of some amount that we are going to receive in future, and the future value of some amount that we have today in our pocket or in our bank account. Then we will construct a loan schedule, and that is called amortizing a loan schedule. And also, we will discuss if the interest rate is compounding more than once per year, then what would be the solution for that. So, you will get to know all these concepts later in this lecture. Let's have a riddle. Which would you prefer? $10,000 today or $10,000 in 5 years? And I can imagine, obviously, your answer would be $10,000 today, because we have learned that the money we have today has more worth than the same amount of money we will get in some future time period, because we have the opportunity to invest that money and earn some return on it. Therefore, if I ask you this question, obviously you will say 10,000 today. Question arises, why time is important? So, time allows you the opportunity to postpone today's consumption and earn interest and get return. If you have to consume some amount today, you can postpone your consumptions and invest that money into some investment opportunity, and you will get some return in the form of either in the form of return or other. But simply we can say we can earn interest. Then we need to understand, is there any type of interest? Yes, there are many types of interests. One is simple interest. Simple interest is when we receive or pay amount on principal that is borrowed. We just pay on principal, then it is called simple interest. And compound interest, that is another type of interest, is when we pay interest on interest that you have already earned. So you have to pay two parts of interest. One you need to pay on principal, another one you need to pay uh, on the interest. In other, or you can say, if you are receiving, then you will receive interest on interest. It is known as compound interest. I'll show you with examples. Here is the formula for simple interest. We have shown here SI, and SI represents simple interest. P, P represents any deposit, or you can use any symbol. Uh, Here we are using P. P naught, naught means zero time period, right? We are talking about zero time period today. T is equal to zero. So today's deposit is P naught. I represents interest rate per period. Interest rate is always uh, associated with period, and normally it is for 1 year. N, number of time period, and usually it is in years, but it could be quarterly, semi-annually, biannually, fortnight, and anything like that. But normally it is in years. So here is an example that you deposit 1000 in an account, like you went to bank and you said, I have $1,000 and I want to invest in some earning opportunity. The bank told you that we will pay you 700 simple interest for 2 years. Like if you want to invest your $1,000, give us $1,000 today, and we will pay you 7% each year for 2 years. So what is the total interest at the end of 2 years? So if we put this into our formula, that interest is equal to P into I on into N. So 1000 would be multiplied by 0.07. 7% would be converted into numeric form, decimal, and multiplied by 2. 2 is time period. So total is 140. So after 2 years, we will get 1140 rupees in total, or 140 is the interest that we have earned on this 1000 rupees. This is simple interest, keep in your mind. Now, what is the future value of deposit? Using simple value, what we have done, we just calculate interest, amount of interest, that's it. Now we are going to understand future value. Like I told you, the deposit we have today, the money we have today has different value in some future if there is some interest rate or earning or return on that. So in our case, if we need to find out future value, that is represented by FV here. P naught is the present deposit plus SI, that is simple interest. So 1000 plus 140 would be future value. This is in the case of simple interest. So the future value is the value at some future time period of some amount that we have today in our hand, and we have invested in some opportunity, and that opportunity is providing an interest rate. Now, present value. The present value is simply, for this example, is 1000 that you have originally deposited. But if we go to the definition of present value, it is known as the current value of a future amount of money or a series of payment evaluated at a given interest rate. Now we need to understand that usually in banks, in financial institution, and in financial management, in corporations, the interest we receive or pay is compound interest. Now we need to understand that what is the difference between compound interest, or what is the effect of compound interest over the period of time if we compare it with simple interest. Here you can see the green color shows a simple interest, that is 10%. Um, uh, Blue one represents 7%, but it is compound, and red one presents 10% compound interest. And if you have deposited single deposit of 1000 in a bank account, and or we can say that we have deposited three three amounts of 1000 in three different bank accounts. One bank account is paying 10% simple interest, another bank account is paying 7% compound interest, another bank account is paying 10% compound interest. Now we need to understand how the value of our deposit will grow over the period of time. If we look at the time period, first year, the amount of interest is equal. But if you look at 10 years, the simple interest rate, that was 10%, and compound interest, that was 7%, both are equal. Look at the amount. Simple interest was 10%, that was 3% higher than this 7% compound interest. But still, after 10 years, both are equal. It seems that compound interest uh, increase the deposit very fastly. Now, if you look at the compound interest of 10%, it is higher than both 10% simple interest and 10% and 7% compound interest after 10 years. And now, if we look forward and go to 20 years, then you can see 10% simple interest is paying less, 7% compound interest is paying more, and 10% compound interest is paying way more. And if we move to 30th year, the simple interest is quite low, and 7% compound interest is quite high, almost double, around double, and 10% compound interest is paying way more, is more than double, it's almost triple. So you can easily understand that compound interest, with the passage of time, compound interest will grow at a very fast rate, because we are receiving interest on interest. In simple words, if you have paid 1000, if you have deposited 1000, and that bank account is paying 7% interest rate, that is compound interest, after 1 year you will receive, uh, for 1000 you will receive 70 and 70. After 1 year, after 2 years, you will earn another 70 on this 1000 deposit, and you will also earn 7% of that 70 you earned in first year. So after that, that would be around $4.9. Then in third year you will receive 7% on this 1000, that would be 70. You will receive 7% on that amount, that on the interest of first year, that was 70. And you will also receive interest on that on the interest you have earned on 70, that is 4.9. So that's way you will earn more over the period of time if the compound interest if the interest is compounding. That's why when you get some loan from the bank, or you have a credit card, and when your limit is crossed, like your paying limit is crossed, then you see that your fine, or your payment is growing very fastly on the, like, for if you delay your payment for 1 month, You, for example, you have to pay 10,000. If you delay it for two months, you, after 2 months they will ask you to pay 13 14,000, and after 3 months maybe it would be around 17 18,000. This is why, because they are using compound interest. Now we are going to understand the how we calculate future value of a single deposit. Like, this is the core concept of time value of money. So we have deposited 1,000, 7% compound interest rate for 2 years. To find out the future value of any amount, you need three things. Number one, present value. Number two, interest rate. Number three, time period. If you have these three things, you can easily find out future value. Before going to find out future value, first you need to draw a timeline like this: zero time period, one time period, and two time period. Here is 2 year. If it is four, then you will draw five. You will draw this timeline up to 5 years. Now, zero time period. The present value is at zero time period. So at zero time period, we have write 1,000. Now, where we need to find out the value of this 1,000 in some future time, that is after 2 years here. So we will uh, draw an arrow, and we will move this arrow to the time period where we need to find out the future value. This 2 represents the time period. So FV2, like future value after two time periods. Here in our case, time periods are years, so these are after 2 years. Now we need to look at the formula for future value. So future value is equal to P naught, like P is the deposit not in zero, P naught zero time period, and deposit at zero time period. Now this is called the future value interest factor 1 plus I represents your interest, and here raised to power n. N is the number of time periods. So if we find out future value for one time period, it would be P present value on you, and you can use PV over here. Instead this P naught, you can use PV into 1 plus I raised to power 1. So here is the answer, 1070. So you earn 70 interest in 1 year. If you look at the amount, if you measure or calculate the future value using simple interest, this was about compound interest, but if you use this formula to not this formula but compounder, this formula is for compounding interest, but for simple interest, if you use the formula for simple interest that we have used earlier, and you can find out that the interest rate at the future value using this interest rate, that is 7%, the value that you have earned after 1 year would be equal, like 70 using compound interest and 70 using simple interest. But if you find out this value for 2 years, what will happen? FV for 2 years. So present value into 1 plus I into 1 plus I. Instead of writing this 1 plus I into 1 plus I, we have a formula: P present value into 1 plus I raised to power n, and if we are calculating for 2 years, then we will use 2 here. So 1000 into 1.07 raised to power 2. The total value is 1144.9. And but if we are using simple interest formula, that is P0 into 1 over 1 plus I into 1 plus I, that would be 1000 into 1.07 1.07 or not, in that way we will be earning 1140. if we use simple interest. But in compounding interest, we are earning more for $4.90 extra. This shows the compounding, because we are earning on the we have earned, or we have received interest on interest. So general future value formula, how we find out future value, that I told you earlier, that future value is equal to present value into 1 plus I raised to power n. N represents number of time periods, I represents interest rate, and P represents present value. Instead of this P naught, you can use PV as you wish. And FVN, N represents number of years. So if you don't like this subscript, don't use it. There is no hard and fast rule. Now we can we can also create a table of future value interest factor. As I told you, this part 1 plus I raised to power n is known as future value interest factor. For this future value interest factor, we can create a table. Here we will write interest rates, and here we will write periods. We can start it from 1%, and we can go to 50%, for 50% or 100%. How we will measure or calculate the values? One time period. What was future value interest factor? It was 1 plus I raised to power n. And if we write it in this form, it is future value interest factor I n. I represents interest, n represents time period. So if I is 6 and time period is 1, then this is the value of future value interest factor. If I is 7 and time period is 1, this is the value for future value interest factor at 7% interest rate, and for first time period. For second time period, 7% interest rate and 2 point time period, it would be 1.145. For 3, for 4, and for 5, it is so on. But how we calculate that? What is the value for how what is the mathematical expression for future value interest factor? The mathematical expression for future value interest factor is, let me take a whiteboard so that you can understand easily. So future value interest factor, this is a simple future value interest factor. We have this for annuities that we will discuss later. Future value interest factor is equal to, the mathematical expression is 1 plus I raised to power n. If we solve it, future value interest factor for 7, like here we need to write I and n. So if we write it like 7%, and this is the comma, let me get a bit clear. Okay, now okay, so So here we need to write the n. For example, if n is 5, then this interest factor would be written as 1 plus I. I was 7%, so we will write 0.07 raised to power 5. So you can easily calculate the value of this interest factor, and you will get the value, and you can put it in that table, or if you are going to solve any problem, you can easily put that value. Let me calculate this. This is 1.07, 1.07 raised to power 5. If you take the power of 1.07, the value would be 1.403, and in this way you can measure the future value interest factor. Now we move again to our slides. So here is the way to uh, calculate future value interest factor, and by using all these percentages and periods that I just showed you, you can construct this type of table, and by using this table you can easily calculate value, or calculate future value for any uh, amount or any deposit. Now you can see 1000 future value interest factor 7%, 2 time periods. So here we will go 7%. It is 2 time period. This value is 1.145. You just need to multiply this value to 1000, and here you got 1145. This is the rounding value. Otherwise, the value was 1144 point something 90. Now we comes to the story problem. Like, if we have a problem in the type of story, then how we can calculate the future value, and how we can understand that what is present value and what is interest rate and what is time period. So here is Julie Miller want to know how large her deposit of 10,000 today will become at a compound annual interest rate of 10% for 5 years. She We can assume that she went to a bank, and she said, I have $10,000, I want to put it in a bank, how much interest you will give me? They said, we will pay you 10% compound interest annually, and you can deposit your money for 5 years, and after 5 years we will return you this amount, principal amount 10,000, and including we will also pay you tax that you will earn over the period of 5 years. Now she want to understand that uh, uh, how much in total she will get after 5 years. So here is number one, you need to draw a timeline. 0 time period, 1, 2, 3, 4, 5. So here, this is 5. You need to find out the value of this deposit 10,000 at the end of 5th year. In 0 time period, present value is 10,000, interest rate is 10%. What we need to do, we need to drag this 10,000 to the end of 5th year, and we need to find out the future value for these 5 time periods. So if we put this and these values into our formula, that was future value is equal to present value into 1 plus I raised to power n. So 10,000 into 1 plus I was 10%, so we will convert it into decimal form, that is 0.10 raised to power 5, 16,105 rupees, 0.10, or 10 penny or 10 paisas in our language. So here is the future value for this type of problem. And if we want to measure these values in this problem on the basis of future value interest factor table, using table, then we will use it like this: 10,000 into future value interest factor, 10%, I is 10%, N is 5. So we need to go and check in table 5% and 10%. Here we have only up to 8%. You can easily see that at the end of book these tables are also given, and you can also construct your own table. Better you construct your own table if you want to calculate using this future value interest factor. So the future value interest factor at 10% for 5 year is 1.611. So 10,000 multiplied by 1.611 is same 16,110. Due to rounding, we have round the figure because here in future value interest factor is in a rounding form. Now the question is, another interesting question is, sometime you will be asked that how long it will take to double some amount, and a compound interest rate is given. Like if you are given that you have 5,000 and the interest rate is 12%, so how long it will take to double your amount? So here is a rule of 72. Uh, we can exactly measure the time period to measure to double this amount 5,000, but the short way is rule 72. And what is rule 72? It is very interesting. You need to divide your interest rate with 72. 72 divided by your interest rate, it will give you the approximate number of periods to double your amount. But if we want to calculate this the number of periods by using our traditional way, we can use it. Let me take a whiteboard and then I will show you. So the question was, amount present value was 5,000. Okay. And interest rate I was 12%. N is unknown. We need to find out the time period. And future value, we at least have three of the values. What is the future value? Double of this 5,000. That would be 10,000. So we need to find out, to make this 5,000 into, we need to convert this 5,000 into 10,000 in some future time period at an interest rate of 12%. How much time we need to wait to make this 5,000 double, that is 10,000? So what was the formula? Formula is to find out the future value that we have already learned. Formula is future value is equal to present value into 1 plus I raised to power n. Sorry, this is 1 plus I. Now what we need to measure? We need to find out this n. What is the way to find out this n? First we need to separate this factor. So we will move this PV to left hand side. If we move this PV to left hand side, the equation would be like this: future value, because it is in multiplication, so it will be divided here we will put it in division. FV over PV is equal to 1 plus I raised to power n. So what is the future value? Future value is 10,000 divide by present value 5,000, that is equal to 1 plus I was 12%, 0.12 raised to power n. So if we divide 10,000 with 5,000, 10,000 divided by 5,000, the answer would be point 0.2 is equal to, if we plus this 1 with 0.12, it would be 1.12 raised to power n. Now what we need to do to make this n over here? Now this n is in power and we need to take it down over here. So what is the solution? We need to take log on both sides. So taking my writing is not good over here, please don't mind. Taking log on both sides. Taking log on both sides. Oh sorry, this one is not 0.2, this one is 2 if you divide 10,000 with 5,000. Okay, so the situation will be like this: log 2, and if you take log of something which is in power, it would be like this: n log 1.12. If we take log of 2, it would be around log of 2 0.301029 0.301029 and we will leave it over here, and log of 1.12, so it would be around 1.12 log. It is 0.04 in your on your scientific calculator. There's a button for log, so you just write the value and then press the button of log, you will get this value. So it is 0.049218 92180. Now what we will do, let me erase some part so we can solve over here. Now what we need to do, we need to make this n alone, so we will shift this one to the left side, and then here it is in multiplication, so it will go in as numerator on left side. So it would be like this: 0.301029 divided by 0.04928 and 0 equal to n. The answer would be 6.1111, and this is how we can calculate the time period if we if the future value and present value and interest rate is given. So if I ask you that the today we have 5,000 and we are gonna put that 5,000 into a bank account at a rate interest rate of 12%, that is compound interest rate, uh, and we need around if I say 20,000 in some future time period, then how long it will take to become 20,000. You just put 20,000 as your future value and uh, use this procedure, and you will get the number of time period uh, that will be required to grow your 5,000 into 20,000. So another shortcut way is this 72 rule that I already told you. Now we need to understand the present value. For example, you need 1,000 after 2 years, but you have some money today. You went to the bank and you asked them that I have some money, but I need 1,000 in 2 years. So how much amount do I need to deposit in your bank to get 1,000 after 2 years? Bank told you that our discount rate, when we uh, use the interest rate to find out the present value, we call it discount rate because we are discounting the future value. In when we are measuring future value or calculating future value, actually we are compounding, that we are applying interest rate. But when we are uh, calculating present value, then we are discounting that interest rate from the future value, because present value, if the amount in a future is 1,000, the present value would always be lesser than 1,000. So bank told us that we are paying 7% annual interest rate. Now go and calculate by yourself like how much amount you need to deposit in your bank. Then what will you do? You will just need to draw a timeline like this: zero time period, one time period, and two time period. Future value, you need 1,000 in 2 years. So at the end of 2 year, 10,000 is your future. Oh, sorry, 1,000 is your future value. You need to find out the value of this future value into present time period, which is zero time period. So present value zero. We need to drag it over here. What is the procedure for this? The formula to find out present value is, we just use the same formula that we use to future value. We just shift present value to left side and future value to right side. So the formula looks like this: future value divided by 1 plus I raised to power n. So in this case, our future value is 10,000. I plus interest rate is 7%, that is 0.07. So total 1 plus 0.07 is 1.07 raised to power your near n is number of years, so raised to power 2. Here is the answer: 873.44. If we deposit $873.44 today, we will get $1,000 after 2 years, or the value of 1,000 after 2 years. The value of 1,000 after or we can say that the amount we will get after 2 year, what is the value of that amount, that is 1,000 today, in today's time period, that is 873. So in this way we can find out present value and future value. In this lecture, we have learned two major concepts. First, we have understand the interest rate, two major concepts of interest rate, that is simple interest and compound interest. Then we understand that how we can find out the present value and future value of some deposit. This is the same way, same formula, and we have used present value interest factor using table that I already showed you in that previous example. For that was for future value. This is for present value. So we will use this formula FV over 1 plus I raised to power n for 1 year. This part, if we separate FV, so this part would be like this. Let me simple it for you. Future value, sorry, present value interest factor I and n is equal to 1 over 1 plus I raised to power n. So if uh, present value interest factor is for 7% and for 5 years, then it would be 1 over 1 plus 0.07 raised to power raised to power 5. So this is future value interest future value interest factor. So here this is the future value interest factor, and you can find out the value, and you can create your own table, and after that you can use that table and that value and put those value over here if as per the requirement according to the INN, and you can get the value. Now this is the same way to find out present value using the table. Now we move to the story problem, yeah, or we can call it word problem. Example: Julie Miller want to know how large of a deposit to make so that the money will grow to 10,000 in 5 years at a discount rate of 10%. So the same, we need to draw a timeline. Future value is 10,000. So 10,000 after 5 years. At the end of 5 years, you can make it like this, or we can consider these as a end of 5 years. So you can uh, uh, make this 10,000 over here, write this 10,000 under 5. We need to okay, we need to drag this amount to the present value 0 time period. So 1, 2, 3, 4, 5. So 5 is our time period, and 10% as interest rate. We will put it in the formula. That is very simple. Present value is equal to future value over 1 plus I raised to power n. I is 10%, 0.10, and n is 5%. So we will divide 10,000 with this interest factor. Amount is 6,209. So she want to deposit 6,209 today, so that she will get 10,000 after 5 years if bank pays her 10% interest rate. Hope you have understand these concepts of time value of money. These are very basic concepts, and in next lecture we will talk about uh, some new concepts of time value of money, like how we can find out future and present value of annuity, where is a stream of deposits are deposited over the period of time, and also we will learn how we can find out the present and future value for mixed stream of deposit where annuity and single deposit are mixed. Uh, uh, and you need to do some assignment work that I will share on Google Classroom. That's all for this lecture. Thank you very much. See you in next lecture.